Think forward. Think Research Channel.
Thanks for joining us on Discovery at Virginia Tech. I'm Paul Lancaster, and we're here today to talk about the Virginia Tech Transportation Institute, involved in a lot of transportation issues across the Commonwealth and across the country. With us today, I want to introduce our three guests left to right. First is Tom Dingus, who's director of the Virginia Tech Transportation Institute. Next to him is Ron Gibbons, who's the group leader of the Lighting and Infrastructure Technologies group in the Center for Advanced Safety Systems at VTTI, and we'll talk about what all that means in a minute. And then next to me is Vicki Neale, who's director of the Center for Human Factors Research, and we'll talk about that a little bit too. But Tom, I want to start out with you, just sort of setting the scene for what VTTI is all about. Talk a little bit about the scope, what you're looking for, the kind of projects you get into in general.
Well, the VTTI is a very large transportation institute in the nation. It's top 5 in terms of size. It has a very diverse research program. We have about 200 faculty, staff, and students working on about 60 to 70 projects at any given time. And they span from the safety and human factors area to the pavement and infrastructure area to the sort of traffic modeling and mobility area. And so we have a lot of faculty on campus and a lot of students doing a lot of different things.
You know, one of the things I want to talk about in terms of, you think of an institute, you think of a bunch of people sitting at computers doing calculations, but you know, an integral part of the institute is what we call the Smart Road. Talk about that a little bit.
Well, the Smart Road is an actual section of highway that's not open to traffic. It's about 2 miles long, and since it's not open to traffic, it means that we can test a lot of things that aren't ready for prime time in terms of being able to be put out in the field. And it's important in transportation to do a lot of that kind of testing because you want the technology and the different things that you're putting out in the field for a variety of beneficial purposes to not have unintended consequences when you put them out there. So we do a lot of testing of in-vehicle systems, systems that may distract drivers, and we want to make sure that they don't. We do a lot of testing of road safety devices. You can hear some about that later. But we also test pavement for pavement life, and we do a lot of roadside technology kind of applications like wireless communications.
We're going to talk about some specifics in a minute as far as some of the work you've been working on, but I want to get to the other folks here. And Vicki, let me turn to you with the Center for Human Factors Research. Obviously, you know, the best vehicle you can have, there's still somebody controlling it or trying to control it in most circumstances, and I guess that's what human factors is all about, determining the human side of transportation issues.
Absolutely. It's really looking at when you introduce a system into either the vehicle or the roadway, how is the driver going to respond with that information? Is it a safety benefit or is it a distraction? And what are the pros and cons of doing that? Are there unintended consequences of the technology that you are putting out there? And those are things that we look at.
You know, and there's a wide scope, obviously, of things you look into. One of the ones I want to talk about, one of the projects, is the intersection collision avoidance work that's being done. First, let's back up. What's the problem that you're looking at as far as that goes?
Well, if you look at the 43,000 fatalities that are occurring nationwide right now, about a quarter of those are intersection related. So intersection work would address about 10,000 fatalities a year, and over half of the injury-related events that are occurring, so over 1 million injury-related events are also intersection-related. And so we're looking at the development and testing of systems to mitigate those crashes.
Let's talk about some basics of the study. I mean, obviously you have an intersection with a stop sign or a stoplight and one car goes through it and there's a chance of an accident. How do you approach solving that problem? I mean, I guess the main thing is alerting the driver that something's not right here.
Yes, and so there are many aspects to this. We're looking at not only the timing of the warning that would be given to the driver, we're looking at the communication system, we're looking at how to know the position of the vehicle in relation to the intersection. There's a whole host of efforts that we're undergoing to look at the architecture for what a final system should look like. And to do that, and to also make sure that the final system that we put out is a benefit, we are looking at testing drivers through a variety of different scenarios. So what happens if there is following traffic? Is a person willing to brake? What happens if there's cross traffic? What happens if there's both? What happens if the traffic density would be high or low? Is there a difference approaching a signalized versus an unsignalized intersection? So a vast variety of combinations of events could lead a driver to respond in a different manner. And so we're not only looking at what's the best way to warn, when's the best time to warn, but what are the consequences of giving those warnings?
Well, I would think there'd be a factor in there if you warn them too early, and this is something that happens consistently, then there's sort of the crying wolf factor that they're not going to pay attention anymore, and that's got to be a consideration.
That is a consideration. You don't want to warn a driver too late because they're getting essentially a false alarm that says they need to stop when they know that they really don't need to stop. You don't want to warn them too late because you don't want them, you could actually increase the potential of a crash at the intersection because they try to brake in response to your system, and then what happens is they get rear-ended, or they're not able to stop until they're in the middle of the intersection. Obviously, you don't want to put them in harm's way with cross traffic. So that timing aspect of the algorithm is extremely important, and so we're looking at ways to, while we're trying to find that nice spot between too early and too late to give the driver a warning.
Well, and not only with an individual, but if you look at the whole line of people who drive, you've got elderly, you've got kids who have just gotten their licenses, you've got people in the middle who have been driving for years. Just trying to figure all that into the equation's got to be complicated too.
It is. The individual differences, not just between older and younger drivers, but male and female drivers. We know that younger male drivers tend to stop later. They'll apply the brakes much later, and they'll brake much harder. And then if you add a warning on top of that, are they coming to a screeching halt and causing rear-end collisions? Whereas you have an older driver who may tend to be much more conservative, or they may decide that you've given them a warning, but they know their own limitations in terms of being able to react soon enough, and so they'll choose to go through the intersection anyway. So all of those kinds of human variables have to play into our final equation.
I found it interesting that one of the things you're looking at is configuring GPS and all those sorts of things into it. I mean, has it gotten that specific where you can tell the exact moment where you need to apply braking sort of deal if you're doing a GPS-based, satellite thousands of miles up in the sky directing this?
Well, the communication system is certainly going to be a factor. That's not necessarily to say that the end architecture that we come up with is going to need to be that complicated, but it is important to know the position of the driver, and we're looking at tenths of seconds. And communicating that information, getting the signal phase and timing from the intersection, throwing all of these factors into the variable, and then warning the driver, and still giving them enough time to respond to whatever warning that you've given them. It's a very well choreographed song and dance by the time you're all finished.
Is there a timetable on this study?
We have two contracts actually right now that are intersection collision avoidance related, and they are being coordinated very closely, and those will end in the spring. And so we're talking about another 6-8 months. And then of course there's going to be follow-on work. We're going to have a lot of the baseline information all put together and good ideas of architecture, but after we're finished with smart road tests, of course we're going to need to do some testing at real intersections, first collecting data without warning the driver, and then working up to where we're confident where we can warn the driver, and hopefully have a deployment at many intersections to do a final field test of the system.
I want to get into some more questions later on if we have time, but I do want to get to our other folks. I do want to mention at this point that there is a website, vtti.vt.edu, and we'll list that at the end of the program, vtti.vt.edu, that you can look for information about the Institute and some of the programs that they're looking at. Ron, let me turn to you. Again, group leader of the Lighting and Infrastructure Technology Group in the Center for Advanced Safety Systems. Long title. One of the things we want to talk about is the wet nighttime visibility of pavement markings and guidelines for crosswalk lighting. Let's start with the nighttime visibility. What are the issues there?
The primary issue we're looking at is how visible a pavement marking is at night in a wet condition. So what we're doing there is we've all sort of experienced it. You're driving down the road gets wet, and the pavement markings disappear. And what's happening there, in some cases, the optics are flooding the optics are being flooded by the water, so then the light's just not coming back off of the pavement marking. So we're looking at different technologies that can give a greater distance for the driver to be able to see where the road's going, see the pavement markings, and those sorts of issues.
You know, the only thing I can think about is on interstate highways in Virginia, there's those bumps in the middle of the road with the reflectors that give you some raised kind of surface. Obviously, you don't want to be driving over those sort of deals, so it's got to be a little bit of a complicated issue. You can't just put in bumps everywhere to show the markings.
Yeah, those bumps are actually very expensive.
Yeah.
And so when you get into running snowplows and all those sorts of things over them, that becomes an even greater issue. So we're looking for a technology that can be applied with a reduced cost, but still gives the same benefit of the little retroreflective bumps.
Let me ask you kind of a broader question of who's interested in this kind of technology. Who are you working with? What kind of outside groups are involved in this?
It's actually interesting. The Virginia Department of Transportation did a survey, and this popped up to the top of their list as one of their greatest issues that they have, or the driving public has with the roadway. So Virginia's interested, but then also the Federal Highway Administration's also picked up the same banner, and so it's actually a nationwide issue that we're trying to deal with.
I want to ask about the crosswalk lighting guidelines. I'm particularly interested because I've had a friend who was hit in the crosswalk, and obviously somebody didn't see something and things didn't work right. Do we have data on the numbers of accidents? How big a problem is this?
Typically, nighttime driving accidents are significant from the standpoint of you have fewer driving miles, but a higher proportion of accidents. There was a study done in Orlando where they of pedestrian vehicle to pedestrian accidents, about 56% of them happened at night, when there's much fewer things going on at night and some of those. Then when you looked at fatal crashes where the pedestrian was killed, the breakdown went down to there was about half as many on a lit road, so a road with lighting, versus an unlit road, a dark road. So that shows you the impact of the lighting on that particular statistic.
Well, the problem then to me becomes you can't light every place in the country, sort of deal. So what kind of options are you looking at? How do you make it safer at a crosswalk?
Well, we're looking primarily at guidelines for what we would call vertical illumination. So that's the amount of light falling on the surface of the person. And looking at it both from the standpoint of headlamps and then from the standpoint of overhead lighting. And my primary interest in the project is overhead lighting. So we're looking at developing recommendations that can be implemented from a lighting design standpoint, and giving an actual number that says it must be this in the crosswalk in order to be safe.
You're looking at overhead, but you also did mention headlamps, and I know there's been some looking at different kinds of headlamps. Ultraviolet A lightings tends to show up, I guess, clothing and stuff like that better. Can you talk about that a little bit?
UVA, of course, is the safe part of the UV spectrums, and what the aspect of that is, we're looking at putting those adding a UVA component into your headlamp. And what it does is, UVA is primarily, if you can reckon it to black light. We've all seen black light where you sort of shine. And that works really well on light clothing, clothing that's been washed with a detergent that has a phosphor in it. That will retroreflect. But it doesn't work on dark objects. So a tire tread, a block in the middle of the road, a pedestrian wearing black clothing, and things like that. So it's a good addition in some ways, and it's a deterrent in other ways. And humans, unfortunately, are infinitely adaptable. So we say, oh, well, we can see all these pedestrians really well because they're brighter, but then you have an object that isn't brighter, and you're almost overdriving your headlamps.
Got a couple more questions. I may want to try to get back if we have time, but I want to turn to Tom and ask about this wonderful study we did in Northern Virginia. Let's kind of set the scene what the study involved, and then we'll talk about some of the things we found out of it. Talk about the study itself. It was a pretty massive study for a first time out kind of thing.
It was very massive. It's the largest of its kind ever attempted, but the impetus for the study was we don't have very good crash causation data. In other words, you look at crash databases where police come out and they fill out a report, and then which is essentially a one-page piece of paper, and then that all gets accumulated into a driving crash database. You can imagine that there's a lot of data missing. I mean, the police just don't have the opportunity all the time to gather all the information. People don't remember oftentimes. And so what was happening just prior to the crash, what the driver was doing, and what really the circumstances and causal factors were is really not well known. So the goal of this study was to instrument 100 cars with cameras and other sensors, including radars and accelerometers, so we could really analyze the 30 seconds, 10 seconds, and 3 seconds before a crash or a near crash occurred. And so we had these 100 cars on the road for over a year and collected roughly 30,000 hours of driving data to begin to address this kind of problem.
You know, all that data, and to me, the amazing thing, I believe there were about 50 accidents and about 1,000 near accidents.
Well, you have to understand that we see it all. I
Yeah.
mean, so unlike a normal accident where if there's an injury, an ambulance is called, or if there's significant property damage, the police are called. We see other vehicle contact, if you will, or collisions that aren't that severe. Mm-hmm. So, yeah, if you count them all, it was actually 76, where you had some kind of contact at relatively high speed with a vehicle. We had 5 airbag or injury-related crashes, a number of police reported, and then a number of these lower contact crashes. But yes, we did have almost 1,000 near crashes, where the only real difference between a crash and a near crash is the presence of an evasive maneuver that was successful.
You know, and just to set the scene for those who aren't aware, Northern Virginia is the suburb of Washington, very heavy traffic. So the expectation of some sort of accidents or near accidents was not, or was anticipated, I guess. I want to talk about, obviously, just so much data out of this still being compiled, but I want to talk about some of the data about distractions that was uncovered. What can you tell us about distractions being a cause of accidents or near accidents?
Well, distractions was a very big factor in what leads to crashes, and we're still analyzing the data. It's very preliminary, but we did find some very interesting things. For example, the biggest source of distraction for our study, which again was the most comprehensive of its type, were cell phones. A lot of cell phone dialing, a lot of cell phone conversations were definitely causal factors with respect to crashes. One thing that we also found is that a lot of crashes occurred not when the driver was distracted per se, but when they were engaged in the driving task, either checking a mirror or a blind spot. Something would happen right at that very moment in front of them, and they would crash. Another thing that I found very interesting is we had 22 rear-end crashes, and 19 of the 22 did not involve following too closely. And so what I believe is happening is that, instead of a driver tailgating and getting into trouble, more often it's the case where the driver creates a gap and feels comfortable and then engages in something like a cell phone task or a conversation or something like that, and then they get into trouble.
I guess one of the things that I found interesting was that you seem to note a difference between talking on a cell phone and having a conversation with somebody else in the vehicle. Can you talk about that a little bit?
Yeah, we did, we monitored both, of course, and, cell phone related conversations were roughly involved in twice the number of incidents as having a conversation with a passenger. And there's several reasons for that, people believe, and one of them is that when you're engaged in a conversation with a passenger, they're in the driving context with you. So if something happens and you delay your conversation for even 4 or 5 seconds, they're right there with you and they understand why. Whereas with a cell phone, there's a tendency, for reasons of being polite, to try to continue the conversation, maybe in circumstances where you shouldn't because the people aren't in the context. So that's just one of several possible causes, but there is definitely an effect there.
You talk about cell phones, talk about fiddling with the rear view mirror. Every day it seems we're having some sort of new technology introduced that everybody has to have, and there's going to be more gadgets, there's going to be more things in the car or the vehicle happening. Isn't this only going to get worse, the possibility of distractions?
I think it is going to get worse before it gets better. One thing that we saw in our study was, you notice the younger drivers, the drivers under age 25, were doing a lot more things with their cell phones. They weren't just talking on them, they were text messaging, and they were reading them, and they were screening calls because they got a lot of calls and things like that. And you can just see with the increase in capabilities of these wireless devices that there's a real potential there for a problem.
What's going to happen to this information? How's it going to be presented? Who's going to find out about this? Who are the interested parties here?
Well, it turns out this is a little bit of an unusual study. There will be a final report, and the final report will be out in about 5 or 6 months. But beyond that, we really hope that the database is used by a variety of researchers to answer a huge number of questions. And so that's one of the real features. And the database itself will be public domain and will be available for a lot of different organizations to use.
We talk about the gadgets and everything, and let me turn to the human factor side of it. And when you're looking at something like intersection collision avoidance, obviously that plays a role too. And if there's even more gadgets, that's going to become more of a problem as well, isn't it? And just in terms of general human factors related to transportation.
Well, certainly anytime you're talking about designing a warning in a vehicle, you have to consider what other devices are in or around the car that would be competing for the driver's attention. So for example, visual displays for an intersection collision warning may not be a very good solution to the problem, because what happens is that when somebody finally determines that they're in a position where they are getting a warning, they're looking around the intersection, not just looking ahead, seeing the light and saying, oh, I got to stop. For some reason, people feel this need to assess what is happening. And so the types of warnings are certainly going to be a big question for us.
And Ron, a question for you as far as crosswalk lighting and pavement markings. You still got to get the person to pay attention, and that's got to be a consideration in the research you're doing too, is some people just aren't going to pay that much attention.
Yeah, really our goal in lighting a crosswalk is to make the object in the crosswalk so that it draws the attention of the person. So if you've got a pedestrian standing in the crosswalk, even if they're looking down at the radio, something will happen to them that they're able to look up and see the pedestrian. So we're trying to make all these objects as bright as we possibly can make them, and that's so we can draw their attention.
Tom, we've got a couple minutes left. We're actually running out of time. I want to talk a little bit more about the scope. We've mentioned a couple of projects that VTTI is working on. Can you give me some examples of some of the other things that they're looking at? I know, for example, the Smart Road can produce fog and snow, and that figures into some of the research that you're working on. Yeah,
we do a lot of visibility-related research, some of the stuff that Ron discussed. But we also, yes, have the capability to make fog and snow, so we do some winter maintenance kind of work. For example, we're interested in and have tested some what are called anti-icing agents. Currently in the U.S., what's done is called de-icing. That's where you wait until the road is slick and then you go out and treat it to try to make it not slick. In Europe, they use anti-icing so that if you have the technology to predict when the road's going to freeze, you apply a liquid to it so that it never freezes, which is a much safer kind of thing to do. So we do a lot of that kind of testing. We also have projects. We have a group called the Center for technology deployment. They work around the state and the nation building public-private partnerships to actually implement things out on the roadway. So for example, if you drive up and down I-81, there's the 511 Virginia system, which provides a variety of different kinds of information, including safety-related information about weather and traffic. We actually designed and implemented that system, and we run it out of our building. We have another center at the Center for Sustainable Mobility. They do a lot of work in trying to improve the efficiency of the roadways and trying to determine how to get cars through more smoothly and keep the mobility very high, reducing traffic congestion and things like that.
And of course, a lot more beyond that, and maybe we'll get together another time and talk about some more because there's just so much going on. Again, it's vtti.vt.edu, and we'll have that listed at the end of the program as well. I want to thank our guests for joining us from the Virginia Tech Transportation Institute, and thank you for joining us on Discovery at Virginia Tech.